Good afternoon, everyone, and welcome to Tangled Testing. Today we're looking at NGO 4043 standard filament created by tangledfilament.com. We did it in both black and in gray so that you can see how these materials behave when printed. Now, before we show the actual test results, let's talk about the actual test setup. Now, we are using a calibrated tensile test machine, which allows us to get very accurate force readings on the amount of pulling force required to break one of these. These samples themselves are produced in batches of 10, all vertically printed in a single batch of 10 in order to make sure that a single machine is consistent and reliable in producing all of them, and there are no heat concentrations that can change the isotropic nature of a 3D printed part. Now, this does mean that the layers are crosswise of the sample. This is what we are most interested in. Within all given research thus far, everybody knows that if a part is printed horizontally, that its strength is about 90% that of a traditional isotropic molded part. But the layer lines and the layer adhesion is where 3D printed parts often break down, because quite frankly, everybody knows them for that, which actually wasn't that bad of a demo in all context. But the layer adhesion is the issue that causes issues. So we always want to create samples where it's printed vertically because that tests the process most accurately. These samples are 13 millimeters by 4 millimeters deep and have all been measured and verified as such. Again, produced on the same machine over and over again, so you know that between a sample set of 10, there's not machine variability in between. Tangled Filament is pure extruded NGO 4043. There are no plasticizers added, there are no other additives added aside from the colorant itself, which is kind of one of the interesting points of this test. Does black create a stronger part than gray colorant, which often has whites added to it, which can contain titanium dioxide, which can mess with the performance of the part itself? Now, here at Tangled, we do produce it with a lower density of gray than you would normally find in some other filaments, so that might not be as much of a factor as we expect. NGO 4043 has been produced for a long time. The resin itself is generally considered kind of a yellowish clear when it doesn't have colorant added to it. The tensile strength for NGO 4043 is 8,700 megapascals, and down the break yield is at 7,700 megapascals. So somewhere in that range is where you want to see the break. But again, since we're looking at the adhesion of the layers, we would expect it to be weaker when pulled down at those levels, because you're dealing not necessarily with the inherent strength of the material itself, but its ability to stick to itself as layers are put down. So the hypothesis in this test would be that it is weaker by a fairly large margin. Again, in past research, generally you see that 3D printed parts along the layer lines have about 50 or less % of the strength in the vertical. Now, just a side note on this as well, many people look at that and say, 3D printing is weaker. No, it's just non-isotropic. 3D printing has the advantage of being able to create really odd and thick geometries. Even though this cross-section might break below what the actual strength of the material is, part of the reason of these tests is to quantify how much that is for a particular material, in this case NGO 4043, but then also to educate about how to design for this. If you want this stronger, just triple up the thickness, and now you have a part that is strong as before, and you don't have the shrinkage problems of molding. So with that, let's go ahead and dive in. Each one of these tests was conducted with 10 samples in order to make sure that there was consistency. Over time, we will continue to expand that number to make sure that data is staying consistent throughout, but just within the limitations of time of producing these videos, 10 samples is the place to start. So again, batch of 10 of these, placed into the extruder following standard ASTM standards. The sample size, again, is a 13 by 4 cross section with the dog leg flanges up at the top to make sure that the clamps are able to get a hold of it. When we tested these, we started off with black, and each one of the tests was able to pop off just beautifully. PLA is a naturally very brittle material, so you do not see it stretch and elongate over time, so you don't have any sort of plastic range in the charts. All you see is it pulls harder and harder until it breaks. So the tensile strength for NGO 4043 is 60 megapascals, or down as low as 53 megapascals if you're going down there. So it's pretty darn strong. For a cross section like this, that would convert into about 1,000 pounds of force, a little bit more than that at yield. So that is what we would be expecting in these tests. However, since we're printing them across the layer lines, historically research has shown that layers create about a 50% to 30% the same amount of strength as the actual material itself, because parts just don't adhere to themselves very well, and cooling can affect that a bunch. But let's go ahead and dive into the test and actually see what happens. We loaded these up onto our machine and they broke off just beautifully. Across all of these tests, we had an average force of about 1700 newtons, which is about 300, 400 pounds, that range, which is 2 full-grown men hanging from a cross-section this big. That's pretty darn impressive in the context of material strength in general, especially when you're looking at a plastic. That translates into about 30 to 32 megapascals of stress on these parts, which is about half of what it was projected, which is what we would expect from past research. So at least now we're being accurate. And it was really good to see from these tests that after all of them were conducted, all of them were in the same range, which both indicated that the consistency of our test was pretty well there. Even though there's variability within 3D printing, it was not dramatic. Then of course we went ahead and moved on to the gray itself. The first test was, of course, for black, moving into the second test for gray. This was actually kind of interesting. With the gray PLA, we did see more noise, more variability in the results. It still hovered around the 1700 average, but the differences between these different components was pretty radical, even though these were printed on the same machine with the same raw material. So the colorant does seem to have an effect. We would need to do more testing to get this done, but it's still, clearly there's something special about this that is not special about this. Even though the average strength was still around 1700 newtons of force, there was a lot of variability. And when creating a production piece of material and trying to build out a data set, you don't want that level of variability. So clearly the gray warrants more investigation, and we'll do that in future videos. But overall, this was a good test. It was a good demonstration of our machine and our capabilities, a good verification of our processes. The black was very consistent. The gray had more noise, even though they're produced on the same machine, had the same base material, and the only variable change between these was actually the colorant itself. So it warrants more research into the colorant. Now, this is the only material PLA that we can actually use to do this testing. We have to use in-house tangled filament because straight NGO 4043 doesn't really exist very often. A lot of people add plasticizers, which change the softness and hardness of the material. In future videos, we're going to start testing other manufacturers so that you can see the variability in strengths. This effectively serves as a baseline that we can start comparing against to see how other PLAs compare against purely snow-driven PLA, and then how different colorants affect PLA. So as Tangled continues to expand different colors, you'll get to see how those different colors interact with the resin itself. Over time, the goal of this channel is to build up a data set to where when someone decides to 3D print a part out of gray PLA, they can do the engineering to understand how strong will this be when I design a part around it, and they can actually do the math around it based on the tensile strength of the layers in a 3D printed PLA part. Overall, as far as the print settings of these pieces, they were printed at 215 degrees Celsius and were printed at a fairly slow speed in order to make sure we had maximum layer adhesion. So they were printed about 35-40 millimeters per second. And had basic cooling, but again, since there was a group of them, they each had time to cool, so you don't have heat creep through the parts in order to improve layer adhesion. This is actually a very true test of a traditional 3D printed part, where the nozzle goes and works over here for a while, and then it works over here for a while, where parts have time to cool. So overall, this was a good test and a good baseline of Tangled. Do subscribe and be standing by. The next video coming out will be around carbon fiber PLA, and we'll see if it's actually stronger than just regular old PLA. Have a great day, everybody.